All right, so you have Coach Waisanen and Coach Furiosi here today talking about the types of reactions lab. So as we've been learning, there are 5 main types of reactions. Combination synthesis reaction, both of those are synonyms, decomposition, single and double replacement reactions, and then last but not least, combustion reaction.
That's my favorite reaction. You get to burn stuff in the combustion reaction, so that's a fun one.
Yeah, but that's a boring one in terms of formulas. It's always the same.
It is always the same. So we'll mix it up a little bit and have some fun. You guys at home, this will be the best you can do on getting to actually do the reactions. We'll have some fun with this. You can see them. And if you ever want to come into school after school and do one, maybe we can accommodate you. So you ready to start?
Yep, let's go.
Okay, so reaction number 1, you'll see on the paper. If you want to download this paper, we'll have it attached to there. You can download it and print that file if you want to do that. If not, you can just answer your questions on eCampus. So we're going to start with these labs. We're going to go and do these labs together. We're going to start with the aqueous copper 2 chloride and aluminum, dropped it in there. So we have a test tube. Mr. Furiosi, you want to get the copper chloride?
Here we go. We can see we have copper chloride. Probably can't make out the label too much, but it's got the stereotypical blue color thanks to the electron configuration of copper.
So we're going to take some aluminum and we're going to put it together. I want to drop it in here. And we'll drop it in and cover it.
So I'll just add enough drops to cover the whole thing. We don't want to be too wasteful.
So as we watch this, you'll start to see some things happen. We can come back to it. But this reaction is not immediate like some other reactions. Some reactions happen immediately. This one, what do you see in there? Maybe you can start making out. Do you see some? What do you see, Mr. Furiosi?
I definitely see some bubbles forming. Not sure if you guys can make that out at home, but aluminum definitely doesn't look like aluminum anymore.
So it's bubbling. It's a cold day out, so when you start to feel this, you can see some moisture and some steam on the inside of this. It's giving off some heat.
Yeah, so you can imagine that if you see steam coming up, you definitely know that the water is heating up too, and that's leading to some exothermic reaction, energy release. So
we can see the bubbles on the outside of this aluminum foil, but we also see some weird color change happening. It's a reddish brown substance. When you shake it, you can get it to shake off of the aluminum foil and settle on the bottom. What do you think that is, Mr. Furiosi? We'll let them figure that out maybe with their reaction, right?
Yep. There's only a few things that I can imagine that could make that kind of color.
So a nice reddish brown solid that's forming on the outside of this and shaking it off. And we can let this run and revisit it at the end. We'll set that there. We're going to do the next one here. We're going to do the reaction number 3 to get this one going, and we'll come back to this because it takes some time. We're going to take our mass of our crucible. So please record on your data sheet 21.97 is the mass of your crucible. We're now going to add some copper 2 sulfate to that, and then we get you'll want to find the mass of the crucible before heating. So we're going to gently cover a little bit on the bottom. That looks pretty good. So we have these nice blue crystals you can see in here. So now we went from 21.97. Now we're at 23.12 for our overall mass. So you can see on here, we're now going to start heating it. All right, we'll set it on the hot plate, and I'll start my watch. We're going to heat it for 5 minutes, and we'll come back to that one. Why are we heating that, Mr. Furiosi?
Well, I definitely do see a blue color in it. I can already start to hear it fizzing a little bit, and just from the formula itself, we can see that it says copper 2 sulfate pentahydrate. So kind of right here, you can see the pentahydrate a little bit. So I wonder what's going to happen when I heat something that appears to have water in it.
It's a mystery. Good question.
Yeah.
So you can hear it fizzing. Maybe a little bit. I don't know if you can hear that. But this hot plate was already hot, so it should happen pretty quick. In the meantime, let's go ahead and do reaction number 2, which is solutions of cobalt chloride and sodium carbonate. So we're going to do that in a clean test tube. So I'll take the sodium carbonate. I'll go ahead and put this in first because you can see this is a clear solution. I'll just take a little squirt of that. And we have a clear solution.
And there's the cobalt carbonate, which you can see definitely is not a clear and colorless solution.
It's a nice pink. So immediately, that happens instantaneously, a reaction. So I want you to describe what you're seeing here. It looks kind of gelatinous with a little bit of powder to it, to me.
I kind of imagine what like the inside of a marble would be.
Yeah. Good analogy. Like you have a clear marble and it looks like a little cat eye or something that's inside of that, but it looks a little gelatinous, a little powdery.
Yeah.
It's kind of cool, right?
Yeah.
So a nice pink purple color. If you can't see it at home on the screen tool, hopefully you can see it. Trying to hold it over the top of this black to give some contrast. But a nice pink purple solid that formed immediately. It didn't take time. Like this one didn't happen immediately, but now you can see over time this one is starting to, you really should see the color change on number one that's taking place.
You want to know what law I always like to think about with reactions, especially when I'm trying to figure out what's being made? Is the law of conservation of matter. So I know that there's a couple of things that can make this kind of reddish brown color, but if I only have copper, chlorine, and aluminum in it, then that kind of limits what my products could be here.
Very good point. Okay, so we're at about 2 minutes and 30 seconds on the copper sulfate pentahydrate, so we're going to go ahead and go to reaction number 4. Reaction number 4 is really fun. This one is aqueous hydrochloric acid and solid magnesium. Magnesium ribbon looks like this. Alright, so we have this magnesium ribbon. It's very flexible. But we're going to take the smaller of the two and we're going to drop it into some hydrochloric acid. So you're going to see a reaction there. Alright, and then we're going to light a wooden splint. And we're going to hold it over the top of the test tube to see if that gas is flammable. And if the gas is flammable, we know kind of what it is. We don't know if it's hydrogen, if it's oxygen, if it's nitrogen, what is it, chlorine gas, what is it? So Ms. Furiosi's filling that up. We'll fill it, probably give it a little bit more. We'll do about a good amount. There we go.
Say when.
Yeah, say when. So there we go. If we're going to drop it in there, but we have to turn on our gas. And we're going to use our striker. For those of you who have already seen a striker before, but that gives you a little spark here. We're going to turn on our gas and we're going to get ready to light our wooden splint. So we have the flame going. The flame is just there to light the wooden splint. We're going to drop the magnesium into the hydrochloric acid, and we should see something happen almost immediately. What do you think is going to happen?
Well, personally, this is my favorite reaction of the whole thing. I know that metal and acids, they don't really go well together. So let's see how that works.
Okay, so I'll let Mr. Furiosi hold it with the test tube tongs so he doesn't burn his fingers. Because one of the reactions of this is a whole lot of heat. It gets really hot really fast and a lot of bubbles. So I'm going to light my wooden splint. We're going to get it burning. Watch carefully. Hold it a little lower so you can see it. So we're going to light the gas. Ready? Watch close.
Hey!
Yeah, would you look at that? Wow!
Do it again! Aww.
It doesn't happen usually more than once. We can try it. I don't think it will, but sometimes we get a second reaction out of it. Oh, disappointing. No second reaction, but we have the wooden splint burning. There's glucose in that wooden splint, some carbon, hydrogen, oxygen, and we're burning that as part of a combustion reaction. And then we just ignited the gas that's in here. So
and you can see there's still gas being made too.
That gas is very flammable, and because it's flammable, we ignited it with the wooden splint. So you can see that that gas is still being generated until the magnesium is all used up. Once that magnesium ribbon is all used up, or the amount of hydrogen in the hydrochloric acid is used up, then it will stop. That's a limiting reactants type of question that we will get to later on in this school year. All right, so let's go ahead and get our, we're at 5 minutes. We'll get our mass of our crucible back here. And we'll find its mass. So now we're at 22.68, 7.
I think we need to adjust our camera so we can see it. There we go.
Okay, so we're at 22.67. That's kind of where it settled. 22.67. I'm going to heat it for another 3 minutes. So at 22.67, I'm going to heat this for another 3 minutes and see where it is at that point. And then we can continue. Okay, so we finished 4 of the reactions so far. Reaction 1, 2, 3 we're in the middle of. We just finished 4, which was aqueous hydrochloric acid and solid magnesium. Make sure you write your equations for each one of these. If we haven't talked about it, you're writing a chemical equation for each one of these. You're balancing it, and you're using states of matter. So everything that we've talked about so far, you're doing all of those together. Right? Correct states of matter, correct equations, balance them, and then make sure you write down your observations, and then tell us what reaction type are we dealing with. So you'll be answering all those questions here with the lab. So the next one we're going to do is reaction number 5, which is aqueous sodium hydroxide and copper 2 chloride. So sodium hydroxide, which is a strong base. You'll find this in things like Drano, liquid plumber, red double lye, things that unclog drains. It's very, very corrosive to hair and grease and dirt. So we're going to put a little bit of this in our next test tube. You want to hold that?
It's one of the good times for us to use the word caustic.
Yes. Be careful not to put this on Mr. Furiosi's hands.
That would be very caustic to my hands.
So again, we have a clear aqueous solution of sodium ions and hydroxide ions. We're putting that in there. And now we're going to add some copper 2 chloride to that. And you can see if this reaction is fast, is it slow, what is it? And we're going to see immediately we get a reaction of the sodium hydroxide and the copper 2 chloride.
I seem to see a resemblance. This is blue and now the product has blue in it.
Yes? So that product, you'll have to figure out what is that solid product, what are the aqueous ions that are left over as their spectators, right? And then what is the overall product there, and make sure you balance it. So write the overall equation for that. So we finished reactions 1, 2, 3, 4, and 5. Now reaction 6. At home, I don't think this will be quite as bright, but you don't want to stare at what's getting ready to happen, because if you stare at it, it will hurt your eyes. So we're going to light our flame again. I'm going to let Mr. Furiosi do this.
Ew.
We're going to take...
Forgot about this reaction.
We're going to take magnesium metal. Just make sure when you're doing it, you hold it right here so they can see it. We're going to take magnesium metal, which you can see is still very, very malleable, flexible, and we're going to burn it. You didn't think that metals could always burn, but it's has enough surface area, it's thin enough, it will ignite and catch on fire. And when it burns, it gives off a really, really bright, intense heat.
You might want to turn the camera a little bit. So one of the things, at least firefighters, when they have to deal with this burns so hot that you actually cannot put it out. You could put dry ice directly on this fire that creates, and it would still burn through the dry ice. So I'm going to just get it started. The moment I see a bright light, I'm going to look away.
You can see how bright that is. I don't know if you can see how bright it is on screen, but our eyes are really, we can't stare right at it. I can see it easier on the screen than looking at it in real life because it burns out. Now look at the product. It goes from metal, watch this, right into your hands. I can hold it. It's warm but not hot. And now look at the overall net result. It turns into a whitish gray powder. And your job is to figure out what is that whitish gray powder. When you put magnesium ribbon with oxygen gas and mix those together, what do you get? What type of reaction is that? And what is your overall product? So pretty cool. It goes from a solid metal and a mixture with the gas straight away and makes a new product. So that's reaction number 6. And reaction number 7, we've already seen, which is our wooden splint. We burned it. We know what happens with fire and wood, and we burn those so you can get that reaction there. Make sure that you write down reaction number 7. Okay. And lastly, move this back a little bit so you can see our last result. So we've gone a little bit past the 8-minute mark. We're actually at 11 minutes, which isn't a bad thing, but we can see, has this changed at all? And get our next mass. What was it last time?
Seems a little lighter, doesn't it?
It was 22.67. So I think that we got the first time. What's the purpose of doing it twice? It's lighter than originally, but now it's still 22.67. It looks like we've driven all the water off of it. That was the purpose of that, I think, right?
Yep.
So still 22.67. Make sure you include that. And now you want to take that, and I want you to figure out what is the percent composition of copper sulfate and water in your mixture, and see if it gets close to what it should be originally. Well, it should be, theoretically, what should you get? So we have the copper sulfate. We've done all 7 reactions. We just finished up with that. So now you need to make sure you get your types of reactions, identify those properly, write all your equations, include states of matter, and balance them correctly.
And one little bonus before we wrap up is a lot of times we're taught that chemical reactions are not reversible. There are definitely a lot. Like, you can't really unburn this. So the wooden splint, it's burned, we can't get it back. But let's see right here. Let's try and see if we can put water back into our crucible and see what happens.
Oh, look at what's happening.
Happen to pick a bottle with the water in it. There we go. So we can see that we're reacting and forcing water and the copper 2 sulfate to come back together to make that rehydrated compound again.
So it went from that light gray color back to its blue color. It's not as dark blue as it was because it was really, really intense blue, but we could add more water to it and probably get that color to come back out a little bit. But you can see when you add water back to that and rehydrate it, the dehydrated compound now reforms the crystals.
Cool.
So now you guys have to make sure you get all the rest of your data done. You can finish up the lab and submit it through eCampus. Hope you've enjoyed chemical reaction time with Mr. Furiosi and Coach Waisanen. Or Coach Furiosi and Mr. Waisanen. You can say it either way you want.
Depends on what season we're in. Bye, y'all. Thanks for watching.